Okay, so now we're talking about the free response questions from the practice test. So the U.S. Forest Service is considering additional restrictions on the number of vehicles allowed to enter Yellowstone National Park. This says public reaction. The service asked a random sample, that's good, random, of 150 visitors if they favor the proposal of additional restrictions, whatever that means. Of those 150 people, 89 said yes. Okay. So you're asked to construct and interpret a 99% confidence interval for the proportion of all visitors Yellowstone in favor of the restriction. So we take our sample, and we do a confidence interval, right? Now remember, how do you do a confidence interval? You do this. Because it's going to be a proportion, right? So you do p hat plus or minus z times the square root. It actually should be a much bigger square root. So we'll put all underneath 1 p hat minus 1 minus p hat all over n. So our proportion, our p hat's 89 out of 150, which is roughly, what is that going to be? 89 divided by 150, 0.593. So 0.593. 0.593. Plus or minus, now you're doing a 99% confidence interval. That's 2.576. I have that memorized now, but just do a quick Google search and look it up. P hat, of course, is 0.593 times 1 minus 0.593. And your sample size 150 over 150. The whole thing's square rooted, right? So 0.593 plus or minus, and now let's work it out. 0.593 times 1 minus 0.593 divided by 150 square root times 2.576. So you get 0.103. So you have 0.593 minus that number, which is 0.490, to 0.593 plus that number, which is 0.696. So how do we interpret it? Well, we do this as a text. So you can interpret it a couple ways. Or maybe both. So we are 99% confident that the proportion of all visitors to Yellowstone who will approve of the restrictions is between 0.490 and 0.696. Hold on, let's see if I can try to highlight. That's okay. And let me move that so you guys can read a little better. Here we go. And I want to highlight this part here of all visitors. If you said we're 99% confident that a portion of our sample will approve, that's not what it's about. It's about trying to capture the true population mean or true proportion of people, of all people that are in our population. And population, of course, is all people who are going to visit Yellowstone. So somewhere between 49 to 69.6% will probably approve of these restrictions. Now, say for example, in order for it to pass, they would need, because it's federal land, like they might need a majority, and they might be a little worried because there might be some people who probably, they probably get less than 50%. So, yeah, but 99% confidence interval is obviously pretty wide as well. So now, based on your work in part A, is there convincing us that more than half of visitors? I would say probably not, because you do have that 0.49 part that is kind of sticking like a sore thumb. So I would say probably no, because there is a chance that 49% may say no based upon your confidence interval. So that's what's going on there. Also, another way you could interpret it, if you so desire, is you could say, for part A, the interpret part. Let me type something else here. You could say, if we were to conduct this survey 100 times, then 99% of our CI, of our confidence intervals would capture the true proportion of all US adults which have all visitors to Yellowstone. Now, again, I'm not doing this as a free response test, but that's just yet another way we can kind of think of this. And let me move this. So the first statement is obviously what we really want because it's focused on our specific interval that we made. But a 90% confidence interval, what that means is that if you were to do this 100 times, that of all the intervals we made, 99 of them would have the true proportion in them. And that's based upon using 2.76. And we have to assume normal behavior, meaning that, random, it's done randomly, which is good. Independent, so you want to make sure your sample size, 150, is less than or equal to 1/10 of all visitors. Well, yeah, of course it's going to be. I mean, you have like hundreds of thousands of visitors to Yellowstone. And then you need to make sure your proportion, which is 0.593, if you do 150 times 0.593, you want to make sure you have big enough sample size, has to be larger than or equal to 10. And of course, 150 times 1 minus 0.593 must also be bigger than or equal to 10. And I guess that's what statisticians have found that would actually make these confidence intervals hold true. That, if you do the 90% confidence interval, that if you have a large enough sample size, like 10 seems to be kind of that magic number, that you could be sure that the confidence level is correct. That it would, it is going to yield what we're looking for. That yes, 90% confidence interval. That means that if you run the sample 100 times, 99 of those intervals would capture the true mean. Okay, let's do this again for 12, and then for 13, and then we'll wrap up class. And then what I'll do is I'll let this recording download. I'll upload to YouTube. I'll share the link with you guys. I'll put in the week 3/4. I'll put an update if you guys want to watch this again. If you think it'll help you before you do the test. And then I'll also put a format sheet. If you haven't done that yet, that should be real easy. It shouldn't be too hard for me. I'll put in the week 3/4 full, and I have to give you the password also. It is password protected. And we'll play a little game with it, which I like to do. Okay, so this we don't have to create a confidence interval. They say many people have asked the question, but if you have been patient enough to collect the data, how many licks does it take to get to the center of a Tootsie Pop? Actually, I remember that as a kid. I remember when I used to get a haircut. I used to go to this old school barbershop. I grew up in Fremont. my brother and I would love to get these Tootsie Pops. I remember there was a commercial. It was a little owl. It's like probably from the 50s or 60s. I grew up in the 80s, and you would like how many times would you have to lick the lollipop until you get to the center of it? And it's like this sphere shaped lollipop. Anyway, I'm sure that would be really hard to measure anyway. After some intense research revealed 95% constant interval that the mean number of licks to get to the center of the pop is that. Okay. All right. So interpret it. So the way you would interpret this would be we are 95% confident that the true mean of the number of licks to get to the center of a Tootsie Pop among all people who buy a Tootsie Pop or consume a Tootsie Pop is between 317.64 and 394.56. There we go. And let me resize that. Yeah, so that's all it's saying. And again, of all people. And then calculate the point estimate margin of error. So the point estimate is going to be halfway between these two numbers. The point estimate is just 317.64 plus 394.56 divided by 2. So it's just the average of those two numbers, 319.64 divided, sorry, 317.64 plus 394.56 divided by 2, so 356.1. And then the margin of error. So what you do is that you have to take the difference between the high and the low of your interval and divide that by 2, because the range, of course, is the high minus the low. That's easy. And if you divide it by 2, so you get 76.92. When you subtract it, you divide by 2, it's 38.46. So your confidence interval is going to be, could also be rewritten like this: 356.1 plus or minus 38.46. That way you guarantee, actually, hold on a sec. Yeah, that way you guarantee that you get the far left, which is 370.64, the far right, 394.56. And the name two things we could do is decrease the margin of error. So you could increase n, increase your sample size, which is your sample size. Because if you do that, that will decrease the margin of error, because remember, sigma over root n, or root p times 1 minus p for doing a proportion over root n. We're not doing the proportion here because you're actually given an exact number for the number of licks. But if if it's more like percentages as proportions, like the percentage of people who might approve of something or something like that. If you make n bigger, then of course that makes the standard. This is a standard error, by the way. This is a standard error. Margin of error is when you have z. So standard error is that part, or this with a sigma. But the whole thing is called the margin of error. You multiply by z. So if you do want to make the margin of error smaller, you could also lower your CI, lower your confidence level. But another way you could do it as well is lower your confidence level. Because if you lower the confidence level, it makes the window tighter. Now remember, when you do a big confidence like 99, like you go for 95, 99, you're catching a wider net, right? And so you're going to have, you're going to be more confident. Like if you did 99% confidence for this one, then maybe it'd be from 250 to 450 licks, right? So you're more confident that you're going to be between 250 and 450. But of course, it's not terribly accurate. Now, if we want to decrease margin of error, then you do a smaller confidence level. You're not as confident. Like maybe you want to go from 350 to 370 as the number of licks. So you do a 90% confidence level. Now, what are the drawbacks? Obviously, if you decrease the confidence level, you're not going to be as sure, right? You know, you could be wrong. That's a drawback. For increasing the sample size, the drawback is that it's just going to take you longer to do, because then you have to, you know, study more people looking at a lollipop, and that can take some time. Or you have to survey more people or stuff like that. Okay, last one. So a milk process monitors the number of bacteria per milliliter in raw milk. We see the factor gram sample of 10 of these specimens. That gives the following data. So construct 9% confidence interval, blah, blah, blah. Okay, so we need to get our mean first. X bar is our sample mean. And we could probably even get the standard deviation, because we're not dealing with proportions, so we're dealing with like exact numbers. We're not going to, you know, do that p times 1 minus p thing. And we'll assume the worst standard deviation we get here will be fine for us. So let me compute this. 5370 plus 4890 plus 5100 plus 4500 plus 5260 plus 5150 plus 4900 plus 4760 plus 4700 plus 4870. Oh goodness, 44630. Actually, I'm kind of stupid. I should have actually. Okay, I actually should have punched this in the list, because I didn't have to do this again for the standard deviation. So I kind of goofed there. But anyway, our mean is this. Now let me get the standard deviation here. Let's see. Stats, edits. Five three 4890 5100 4500 5260 5150 4900. Use a Google Sheet, much easier, but I'm using my calculator because I already committed to it. 4870 stats calc, one variable stats. Give it to me, please. I get 254. .67. So now I have to do my X bar is 4950. That's my point. So remember, if you're not doing the proportion, it's just X bar plus or minus your Z score times times sigma over root n. And remember, you're doing the population standard deviation. So if you do it in a Google Sheet, you're doing standard deviation p, because you are looking at this whole population here. And the difference between this and this sample standard deviation is that the sample standard deviation divides by n-1. It's kind of a weird formula, but you're doing a population because that's what we want, sigma. So plus or minus your z-score of 90%, which is 1 point, I already forgot, I think it's 645. .645. Okay, so I wasn't that far off, or actually I was right. 1.645 times sigma, which I got was 254.67. My sample size is 10. I have 10 samples here, and we just let the calculator do its magic. 4950 plus or minus 132.48. So if I add that to 132.48, that's 5082.48, or if I do 4950 minus that number, I get 4817.52. So, I'm 90% confident that the amount of bacteria per milliliter raw milk would be between those two numbers. So that's what it tells me. Okay, perfect. So we finished a little early. So let me stop the recording.